Today we are going to be talking about properties of trig functions. By the end of this video, you should be able to apply the basic trig functions. You should be able to review finding trig values of all angles, and you should be able to use the calculator to estimate trig values. First, identities are statements that remain true for all values of the angle. In Algebra 1, you learned about some identities. For example, x plus 2 equals x plus 2 is true for all values of x. This is by the reflexive property. But statements like x plus 2 equals 8 are not identities because they are not true for all values of x. This particular one is only true when x equals 6. So we're going to talk about three different types of identities today. The first are reciprocal identities. And we've already looked at a few of these. You already know that cosecant of theta is 1 over sine of theta, secant of theta is 1 over cosine of theta, and cotangent of theta is 1 over tangent of theta. Well, this means that sine of theta is also equal to 1 over cosine of theta, cosine of theta is also equal to 1 over secant of theta, and tangent of theta is equal to 1 over cotangent of theta. The quotient identities we've looked at sort of. The first one, tangent of theta equals sine theta over cosine theta, we've looked at but in a different way. We've said that sine of theta is y, cosine of theta is x. And we've already talked about the fact that tangent of theta is equal to y divided by x. So this is just another way of writing what we've already discussed. Since we know that cotangent is the reciprocal of tangent, then we know that cotangent of theta is equal to cosine theta over sine theta, or x over y. Next, we're going to take a look at the Pythagorean identities. But before we do that, let's look at the equation of the unit circle. We already discussed equations of circles at the beginning of the year. We know that the general form for the equation of a circle is x minus h squared plus y minus k squared equals r squared. Since the unit circle is centered at 0, 0, h and k are both 0, and we have said that the radius is 1. So we have that this is an equation for the unit circle. And we can switch the x and y around so that we can see how this relates to our first Pythagorean identity. We have said that sine of theta is equal to y and cosine of theta is equal to x. So we have our first Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. This could also be rewritten so that you have 1 minus sine squared of theta equals cosine squared of theta, or 1 minus cosine squared of theta equals sine squared of theta. You need to be able to recognize in any of these three forms that this is a Pythagorean identity. Now, there are two other Pythagorean identities. I always had a hard time remembering them, so I'm going to show you a trick. You can either remember my trick or you can memorize the formulas for yourself. If I take this first Pythagorean identity, sine squared theta plus cosine squared theta equals 1, and I divide all of the terms by sine squared theta, and simplify, I get another Pythagorean identity. Sine squared theta divided by sine squared theta is 1. cosine squared theta divided by sine squared theta, well, we can use a quotient property that we just learned. Cosine of theta divided by sine of theta is cotangent of theta. So cosine squared theta divided by sine squared theta is cotangent squared of theta. Since we know that 1 over sine theta is cosecant theta, then 1 over sine squared theta is cosecant squared theta. So this is another Pythagorean identity. Similarly, if I take our first identity and I divide everything by cosine squared theta, I get another Pythagorean identity. We know from our quotient identities that sine theta over cosine theta is tangent of theta. So sine squared theta over cosine squared theta is tangent squared theta. Cosine squared theta divided by cosine squared theta is 1. And since we know that 1 over cosine of theta is secant of theta, 1 over cosine squared of theta equals secant squared of theta. So this is our third Pythagorean identity. Before we go on, I want to clarify one thing. If I have cosine of theta and I square it, I write that as cosine squared theta, not cosine theta squared. This one means that the angle theta is squared, not that the value of the function is squared. Now, let's apply some of these identities. We have tangent of 20 degrees minus sine of 20 degrees over cosine of 20 degrees. Well, by using quotient property, we know that sine of 20 degrees over cosine of 20 degrees is tangent of 20 degrees. So we just have tangent of 20 degrees minus tangent of 20 degrees, which is clearly 0. Next, we have sine squared of pi over 12 plus 1 over secant squared of pi over 12. Well, by using the reciprocal, we know that 1 over secant squared of pi over 12 is cosine squared pi over 12. So I have sine squared pi over 12 plus cosine squared pi over 12. Well, this is a Pythagorean identity. Because I have sine squared plus cosine squared of the same angle. So my final answer is just 1. Next, we are told that beta lies in quadrant 1 and cosine of beta is 3 over 7. We want to find sine of beta and tangent of beta. So let's draw a picture. We know that beta is in quadrant 1. And we know that cosine of beta is 3 over 7. By SOHCAHTOA, we know that cosine is adjacent over hypotenuse. So we have that the adjacent side is 3 and the hypotenuse is 7. We can use the Pythagorean theorem to find the other side, which is y. So we have 49 equals 9 plus y squared. So y squared is 40. And y is square root of 40, which simplifies to 2 square root of 10. Then we can find sine of beta and tangent of beta. sine is opposite over hypotenuse, which is 2 squared root of 10 over 7. Tangent is opposite over adjacent, so 2 squared root of 10 over 3. Next, we are told that sine of theta equals 1/3 and cosine of theta is less than 0 or negative. We need to find the other 5 trig functions. So, since cosine is less than 0 or negative, that means that the x value is negative. We have a positive sine value, so our angle is going to be in quadrant 2. We know that sine is opposite over hypotenuse, and we can use the Pythagorean theorem to find the other side, which is our x value. So we have 9 equals 1 plus x squared, so x squared equals 8. X is square root of 8, which simplifies to 2 square root of 2. Since we're in quadrant 2, this has to be a negative value. Now we can find the other trig functions. We are given that sine of theta is 1 over 3. We know that cosine theta is adjacent over hypotenuse, so negative 2 square root of 2 over 3. And we know that tangent is opposite over adjacent, so we have 1 over negative 2 square root of 2. We need to rationalize the denominator by multiplying by square root of 2 over square root of 2. So we get that tangent of theta is equal to negative square root of 2 over 4. Then we can do the reciprocal to find the other 3 trig functions. Cosecant of theta is 3. Secant of theta is 3 over negative 2 square root of 2. We need to rationalize the denominator. So we end up with secant of theta is negative 3 square root of 2 over 4. Then, when I find cotangent of theta, I'm going to go back to the original ratio that I used for tangent of theta and do the reciprocal of that. So I just get negative 2 square root of 2. That way I have less rationalizing to do than if I did the reciprocal of my final answer for tangent. The last thing we're going to do today is practice using the calculator. You need to make sure that you are in the correct mode for each problem that you do. Our first problem is cosine of 28 degrees. You can see that I'm already in degree mode, so I can just type cosine of 28 degrees. And I'm going to round to 3 decimal places, so I have 0.883. Next, I want to find secant of 28 degrees. We know that secant is 1 over cosine, so that means that this is equal to 1 over cosine of 28 degrees. So I can do 1 divided by my previous answer, and I get 1.133. Lastly, I have cotangent of 2 pi over 5. This is not degrees, so I need to go back to mode and change back to radians. Since I want the cotangent, I know that that is 1 over the tangent of 2 pi over 5. So I have 1 divided by tangent of 2 pi over 5. And I get 0.325.